Hi, I am Mahbubul Haq, and my pattern would be the object pool pattern. Let's go ahead and begin with the introduction, its intent. Basically, what this pattern is, it is a creation or design pattern that keeps an already initialized set of objects in a pool. So a few examples are an array, a list, etc. Basically anything that can keep a list of objects. In order to use an object in the pool, the client will send a request for an object. If there are objects available, it will be given to the client. Otherwise, based on the implementation, the class will tell the client to wait, or it will create a new object, add it to the pool, and give the client the new object. Basically, there are two different ways of implementing this. I mean, you can do one, you can do both. It does not matter in which program you do it. So the first type of way is the limited resources. So basically, if there are a certain amount of resources that you can actually check out, then that's one way to do it. Another way is unlimited. Basically, if you don't care how much objects are being initialized, you just care that there is at least a minimum set. That's the unlimited resource. Basically, if you request an object, if it doesn't exist, it will still give you something back, but it will just increase in memory. So once the client is done with the object, it is returned to the pool in a ready state instead of being destroyed. So the motivation and structure. The object pooling should be used when there are a large number of objects that need to be worked with one at a time and the object's initialization cost is high. So I thought of an example real quick here, and I'll just go ahead and read this. Basically, the example I give is in a work environment where users need to access saved documents. Basically, initializing a saved document may require the program to send a request to a web service that is connected to a database that may be hosted externally to their environment, and then load the document text with all formatting within the program. This initialization may take several seconds to minutes. Well, the reason for this is because it is unknown. We don't know how long it will take. There's just too many factors to think about here. I mean, network connectivity, connection speed, how many workers are actually hitting the database at the same time. So it's really unknown here. In such a case, a document may not be edited while another user is editing the document. In this example, a limited resource object pooling is desirable. The object pool class will hold some sort of list of the objects, whether it be an array or linked list. A method is implemented to obtain an object, and based on the implementation, again, which I explained in the previous slide, it will either return it or it will let the client know that it can't return it. A method is implemented to release the object and add it back to a ready state on the pool. A method is implemented to clear the object and reset it back to a ready state. And finally, the object pool class itself is recommended to use a singleton pattern. The benefits. Basically, there are two main benefits to this. It can offer significant performance boosts as all objects are already instantiated and are reused. Basically, the main reason you would want to use such a pattern. The pool object is obtained in predictable time. Again, going back to my previous slide here, the time is unpredictable. When you are working in such a case, there's just too many factors. But when using the object pooling, it is predictable. So the consequences, since all objects are already initialized, this can hamper memory usage. It is recommended to use a low number of objects whenever possible. It is easy to forget to clear and reset the object when the client is done with it. So here's an example. The object contains a password, but it is not cleared when returned to the pool. Now, of course, this can provide several downsides here. The second client or third client can get that password. If the objects are not handled properly when returning it back to the pool, it may cause memory leaks. Known uses, I mean, the most widely, I would say, is game design, accessing and releasing several textures, images, objects, sound files, and several other things. Managing documents and managing inventory. So I prepared a demo, and basically I'll go over it here. What this demo is, we're just going to say it is a library that manages check-ins and checkouts of books. So basically our pool, which is our design here, our pool is our books. The library has two different books that are limited edition. So basically I wanted to use both of the implementations of this design pattern. So as I've talked about in my second slide, you can have an implementation of limited resources or unlimited resources. So for my first point, the library has two different books that are limited edition. The books are rare and the library only has so many of each book. A new one cannot be ordered. So this is limited resource. Book A, 5, book B, 10. Second one, which is the unlimited amount of resources, the library has 3 different books that have a set quantity. If one is not available to simulate this, instantiation process, the library can place an order. Basically, for the demo presentation, we will assume the book arrives instantly and it's given to the client. All right, let's get on with it. So I'm going to go ahead and open a project here. So here I've created some classes. Book A, basically all this is doing is when it's instantiated, it gives it a name. Now, where is this coming from? Basically, book A, book B, UL book A, UL book B, UL book C. So these two books inherit from the limited resource book. Okay. Basically, I set a property here is limited equal to true. So if it's if they inherit from here, this is instantiated here. And then unlimited resources, they are inherited from a class called unlimited resource book, which is limited is set to false. Now both unlimited resource book and limited resource book all inherit from the top base class of resource book, and this is where we set the current user, what user is currently checked out that book, if it is checked out or not. This will help us with the object pooling, the name of the book, and of course if it is limited. So let's go to our actual object pool class. So inside this class, what we are doing is we are keeping a list of our books. So a list of resource books, our book A, our book B, these are our limited resources. These are our unlimited resource lists right here. And what I did here was implement the singleton pattern. So here, the property instance, it will return the instance, right? But this will only be called once. As we can see, let me just collapse everything here. This is private. Okay, so you cannot call it. The only way to get access to the object pool is to call this variable, which will return the already instantiated instance, which is only done once. I added a book type enum just to have its name here. Here we have the method add book to list. Basically, we tell what type of book we want to add, and then we will get to the book. So we switch the type. If it's book A, book B, so on and so forth, we add it. But this is done, I mean, there is something done here first. So basically we request the book, okay? So first we pass in a type, what type of book you want. Once we figure out which list to use, which list here based on the type, we will use that and see if there is a book, if it is checked out or not. If it is not checked out, basically what we do is current user is the username, is checked out is equal to, we return the book. If it is checked out, if it is checked out, basically nothing will return. But if nothing returns, we check to see if it is limited. If it is, we return null. If it is not, we add a book, we instantiate a new book, and we return that book right here. Okay, so basically that's, then we do a request check-in. So basically once someone is done with the book, we just check this in. And just for presentations, I'll just try to go through this really quick. We reset the book, so basically once somebody checks it in, we just put everything back to how it was before. Get book type enum as list. This is just for our combo box. It's not anything pertaining to the object pool itself. We get the available count, how many books are available. We get the checked out count, how many books are checked out of that type. And of course, get checked out names, get the names of what are checked out. So let's just go ahead and run this. Let's go into the program. So basically, this is when we get to the main form here. Okay. We don't have to worry about any of this. Is just for my labels that I will show over there when I run this. But basically, in the button click, there will be a button click. When you click on the button, we add the book. So let's go ahead and run this. So this is the program here. We have, suppose we have 5 different students that want to check out books. Their names are Stephen, Mary, Joe, Alice, Carla. What I have here is the labels. So right now, book an availability of 5, availability of 10 for book B, for unlimited resources. These are all available. Nothing is checked out yet. Total here. And this basically will keep track of what users have it checked out. So for Stephen, suppose he wants to check out book A, click on request. There it is. Book A, now there's only 4 available. 1 is checked out, a total of 5. Successfully checked out book to Stephen. And then we can check here, book A, what are the users that checked it out? Stephen. Let's suppose Mary also wants to request this. Okay, so there we go. Everything updated. Stephen, Mary. Joe, we request it. His is in. Alex requests it. His is in. And Carla requests it. His is in. Now, book A, none is available. Checked out 5 total. 5. Remember, this is a limited book. So if any of these students were to check out an additional book here, the library won't be able to order or process it since it's limited edition. And we should get an error message. There are no more remaining books for this limited edition book. Okay, now the only way to check it out is one of these checks it in, and then somebody can check it out. So suppose Carla returns it. Okay, this is available, checked out, is 4. It's done. So and now somebody else can check out another one. So say Stephen checks out 2 of these books. Stephen. Okay, so let's get down with the unlimited resources. So suppose Stephen were to check out unlimited resource book A. Is done. Total of 10 books. So let's just go all the way to. Okay. So there are no more available in the checked out of 10. So since this is an unlimited book, when somebody else tries to request this book, what should happen here is the library should place an order and it should arrive instantly, basically. So suppose Alex wants to request this unlimited resource book here. There is nothing here. Library will make an order, request. Now in the object pool, there are now 11, a total of 11. And now suppose Stephen returns all of his books, and then who else has it? Alex returns his unlimited book. We have a total of 11 in the object pool. Okay, and that's basically what this design pattern is. One thing I forgot to go over is the instantiation process of the object pool. So let's look at what we do here. So here we all basically, when the object pool is instantiated, which is only once at the beginning of the program and never changes, we add in the instantiation process for the book. So here initialize 5 limited resources, initialize 10 limited, initialize 10 unlimited, initialize 10 unlimited, and then initialize 15 unlimited. So all this code is turned in. So yes, that is the program. Thank you.